Hello dear students, this video is made to explain how to solve numericals on the topic Newton's ring experiment. In my earlier video, I have already explained what is Newton's ring experiment, how is the experimental apparatus, what is the procedure to get the radii of bright and dark rings which are observed in the Newton's ring pattern. The link of the video I'll share in the description box. Uh, in that video, you may see the derivation with which we may get radius of dark ring uh, as Rm is equal to under root m lambda r. So that is one formula. Based upon that, there will be certain amount of numerical examples. As far as bright rings in Newton's ring experiment are concerned, for the determination of their radii, we may go for the formula Rm is equal to under root 2m plus 1 lambda r divided by 2. Here in this case, m will be the ring number. Lambda is nothing but the wavelength of light, a monochromatic source of light which is used in the experimental apparatus. And R, capital R, is the radius of curvature of lens. One of the application of Newton's ring experiment is for the determination of wavelength of light. The experiment can be used. To determine the wavelength, there is a formula. Lambda is equal to d square m plus p minus d square m divided by 4pr. Here, basically in the numerator, diameter difference of two different radii is taken, and in denominator you may see there is a term 4. Then p stands for, this small p stands for the difference in between two ring numbers, the rings which we have taken for the analysis. What is relative distance in between that two is considered as the p in this formula. Then capital R, as we have seen on the previous slide, capital R is nothing but radius of curvature of lens. Another application of Newton's ring experiment is that we may determine the refractive index of liquid using the same experiment. To determine the refractive index, the formula is mu is equal to d square m plus p minus d square m in the air medium divided by d square m plus p of liquid minus d square m of liquid. Here, the diameter differences in the air medium and the diameter differences in the liquid medium are selected for the determination of mu. So these are some formulae with which we are going to see the numerical examples. How these formulas are derived, that you may see in the video as I have mentioned earlier. So here is the first statement. Statement is provided as, in Newton's ring experiment, the diameter of 10th ring was found to be 0.5 centimeter and that of 5th ring is 0.25 centimeter. If the radius of curvature of plano-convex lens is 100 centimeter, calculate the wavelength of light used. So whenever you will see the statement, the first thing that you are going to do is to write the given data. In this particular example, the data that is provided is nothing but radius of curvature of lens. Here it is mentioned radius of curvature of lens is 100 centimeter. So we have written that particular thing and we are going to convert it into a SI system. So 100 centimeter is equal to 1 meter. Next to that, it is provided the diameter of 10th ring is 0.5 centimeter and diameter of 5th ring is 0.25 centimeter. So D10 in this particular case is 0.5 centimeter. So we have done the conversion in the SI system. and T5 is 0.25 centimeters, so that will be equal to 0.25 into 10 to the power minus 2 meter. In this particular statement, it is asked to calculate wavelength of light used. So here our interest will be to calculate the value of lambda. So at last it is provided we need to calculate the value of lambda. How to calculate that we are going to see. And we know for the lambda formula is d square m plus p minus d square m divided by 4pr. We are having the value for this d square m plus p. We are having the value for this dm. P will be the relative distance in between the two rings, and r is provided in the numerical statement. So here P is nothing but it is asked, it is given that we are having the 10th ring and 5th ring. So P will be the distance in between that two. So 10 minus 5 it is nothing but the factor 5. So here we may rewrite the formula by putting the values. Lambda is equal to D10 10th ring its diameter square minus 5th ring its diameter square. In denominator we have taken this 4. In our case P is 5 multiplied by 1. Value of D10 and D5 is already provided. So D10 is nothing but 0.5. D5 is 0.25. So we have taken their squares divided by 20. And in the statement you might have, in the given data you might have seen there is a factor 10 to the power minus 2 in both the cases. So we have taken 10 to the power minus 4 by their multiplication. So 0.5 its square will be 0.25, and for 0.25 the square is 0.0625 divided by 4 multiplied by 5 multiplied by 1, it gives you 20. So 0.25 minus 0.0625 divided by 20 into 10 to the power minus 4. So lambda that we may get is 9375 into 10 to the power minus 4 into 10 to the power minus 6. Now do this multiplication. 10 to the power minus 4 into 10 to the power minus 6. So there will be the addition, which is nothing but 10 to the power minus 10. So 10 to the power minus 10 meter is nothing but angstrom. So the answer that we'll get over here is lambda is equal to 9375 angstrom. Another example, here we are going to determine the, we are going to see how to solve numericals related to refractive index determination. So in the statement it is provided that if the diameter of the nth, any nth ring is dark ring in Newton's ring changes from 0.4 centimeter to 0.25 centimeter as liquid is introduced between the lens and plate. Calculate the refractive index of liquid. So here what is given for a particular ring, the diameter in air medium is provided and diameter in the liquid medium is provided. It is asked to calculate the refractive index. So simply here first we are going to see the given data. So dn air is provided, which is nothing but 0.54 centimeter. dn in liquid is provided 0.25 centimeter, and it is asked to calculate mu refractive index. Here we are not going to do any conversion because we are going to take a ratio. So of course whatever are the units, they will be in, if they are in the same system. So we are not going to do any unit conversion. No need to do that. So for mu, here we are going to modify the formula as mu is equal to d square in air medium divided by d square in the liquid medium. So here for our case that will be 0.4 square divided by 0.25 square. So by doing the calculation you will get the value for refractive index as 2.56. Refractive index is the unitless quantity, so no need to give the unit. but whatever are the quantities, you are having the units involved with them, so you have to compulsorily provide the unit. For refractive index, as it is a unitless quantity, no need to give the unit. So here you may give the final conclusion statement as the refractive index of the liquid is nothing but 2.56. So these are some numericals which we have seen related to Newton's ring experiment. In my next video, I am going to talk about the different phenomena of light and the numericals related to that. So thank you for watching.